Stars are whispering tales of old, planets spinning, stories bold. Life is dancing through the night, countless worlds in the starlight. Galaxies full of mystery, infinite in their history. Beyond our dreams and our sights, life blooms in the cosmic lights, dancing on the edge of space. Take me away, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Nebulas with colors bright, birth new wonders in the light. Comets trail their sparkling tears, life endures through the years. In the silence of the void, every heartbeat is enjoyed. From the depths and to the heights, life expands through cosmic night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless
Hey everybody, welcome to Skyter Livestream. It is I, Mark D'Antonio, and we are going to be looking at a bunch of things. Now, I have to tell you right up front, I did check out 3i Atlas earlier, but it's kind of in the west right now. Libra is where it is, and Libra is low to the horizon, and it's brighter by a couple of magnitudes. However, that means that unfortunately, it being so low to the horizon, we're not going to be able to see it. So we're not going to get to image it there. Now, in this scope too, it's the wide field system. The wide field system can't really see small objects that well. Now, 3i Atlas is sporting a small tail right now, and it's also showing a lot of outgassing from the central nucleus and the surface. So we are getting a coma, as it's called. And so its magnitude has been upgraded. It was 17, now it's 14.8. The smaller the number, the brighter it is. Okay, like the sun is minus 26. Okay, so obviously, you know, negative numbers are good. I mean, Vega is directly overhead, and its magnitude is 0. Okay, 0.0. That doesn't mean it's zero brightness. It means that it's actually the standard that we use for magnitudes, it's 0.0, and it also happens to be a star that has these perfect hydrogen lines in its spectrum. So we use it as a standard candle for hydrogen lines and hydrogen emission, or hydrogen absorption lines, sorry, in stars. And so that's something that we always we use and look at. We look at this like that. So that's pretty cool. Now, as far as tonight goes, I'm going to, the telescope has already done a couple of wacky batty things. So we're going to keep using it as if it's not going to do that. And as long as we think positively, maybe it won't. Okay. But as you can see, it hasn't stopped me. I was able to, work on an object right here, which is no big deal. So now what I'm going to do is tell you a little about this. Okay, this is NGC 6823. It is a cluster, and it has a nebula associated with it. You can see the cluster right in here. Okay, and that cluster is actually creating a very, very cool, shape. Brightness. So you can see that cluster right inside that box. And so that's the object that we're looking at right now. That little cluster of stars, however, hot young stars, is actually causing the hydrogen gas to ionize and thus glow orange, or red rather, as we've talked about prior. Okay, so that said, that's pretty cool. And then we'll actually see if we can pull out. We've got 46 images already captured here, and that's doing 25-second exposure. So the telescope's been open a while, so I'm going to just increase this push a little bit. Now you can see all the nebulous detail in this region. Now where are we? We're actually up just near Cygnus. Here's Cygnus the Swan right here. And the swan is visible by turning on our mythology images. You can see it. So we're actually in Vulpecula, which is the fox. And we're right near the Dumbbell Nebula, which we looked at the other night, so we're not going to look at it again tonight. And we're going to come waltzing up in through here and show you some really cool stuff up in Cygnus. And hopefully, with this sitting right like this should be just enough for us to save it and then save it as seen. So now you see this cluster of stars, and many times they are associated with this red nebulous surroundings, like we see in the Lagoon Nebula, if you recall. All right, so that's there. And what I'll do now is we're going to come out of this. This was just sort of our first object to look at. And we're going to go and go into this low light mode that I call it. And we're going to move up to another star system that's beautiful. And it's just up here. This is Albireo. Now, hopefully the telescope won't go haywire, but if it does, I've got you covered. Don't worry. So here we go. All right, and now we should see, there we go, and we should see the stars. There they are, right there. Now, they don't look like much from here, right? But I do want to emphasize that they are really pretty, and they show up rather well once we actually zoom in on them and look at the colors. By moving them, okay, I guess I went a little too far there. So I'll just bring that back, sorry. Okay, let's see how far I went. Oh wow, I went quite a distance. I must have had this set to a farther distance than I wanted to. Yeah, look at that, it was quite a distance. There it is. There they are. And it'll adjust to about here, and then I can adjust it from there. I have to first go here. What do we got? Oh, we're on max. No wonder I didn't set that down to the smaller. Okay, so now we'll head to the west here a little bit, and we'll bring those into the middle. And we'll take an image of these. You're going to love these, the colors. This is Albireo. It's the head of the swan, Cygnus the Swan. And Albireo is a beautiful pair of a K-type star, a giant K-type star, and a B-type star. Now, K's are orange and B's are blue. So it's really kind of a fascinating combo. So I'm going to zoom in just a little, and I did a focus run, but I want to just make sure we're good. It looks like we are, and we are guiding, as you can see with our numbers up there. So I'm going to do a just a 12-second shot. Doesn't need to be much. Okay, and then we'll go into our deep sky mode and show that to you. You can see the colors now, actually, right? But when we go into this live stack here, we'll clear this. All right, and then you'll see Albireo in all its glory. Okay, here it is. Now, it doesn't look like much yet, but that's only because we have one image. And what I'm going to do is take us way down here. All right, and now you can see the colors. These are the halos produced by our optical system. All right, but I want you to see the colors. The colors are just beautiful. This was the first double star I ever looked at as a kid. Look at those colors. Now, getting the data on Albireo, you can see that Albireo, if you look at it right there, it's at the end of, it's basically, as I said, the head of the swan in Cygnus, right? Think of it as the eye, okay? And its distance is about 385.5 light years away. The distance between the stars is, and I measured this and calculated it, it's approximately 5,000 astronomical units that the stars are actually separated by. So considering that Neptune is about 30 astronomical units out, 5,000 astronomical units is pretty substantial, but the stars are still, kind of sort of near each other. But there's talk that maybe it's just a visual binary system and not an actual orbiting binary system. And so that's something to consider. Now let me just put it in the center here, zoom in, and now I'm going to go over here and just do a coordinate solidification here. Get the coordinates on there, so now we're going to be right on it. There we go. All right, so here is Albireo, and let's zoom in so you can see it. Look at that. Look at those colors. Okay. Now the orange star is a K number 3 numeral 3. Okay, or sorry, numeral 2, and that means a giant star. So K3 Roman numeral 2. The K3 is the spectral class, and the luminosity class. How big it is. Is it a supergiant? Is it a regular star like our sun? Our sun is a type V. A V for victory is what's called a dwarf, believe it or not. And the dwarfs are processing hydrogen into helium normally, just like stars do. This star is done with that, and so it's actually swelled in size, so it's past the hydrogen burning, and it's moved on, and it's pretty cool how it works. So it's a K3, number 3, and then Roman numeral 2, luminosity class 2. All right. I'm sorry. I think it's a K8. Sorry. No, K3. I was right. And then the B star is almost an A. It's almost a whitish star, but it's a B9. Okay. And so B9s are still blue. All right. And it's pretty colorful. So I mean, look at that. That's just beautiful. And we can actually go a little further out here, drag this way down, all right, and we can actually see the colors more brilliantly. Look at that. Isn't that something? All right, so what I'll do now is since we're starting with Albireo, I'm gonna grab it like that, and I'm going to make that our target name for now. I'll save this image with annotations. All right, so now that's saved in our Albireo directory. Again, you can get to it. Go to skytourlive.org, and you can get to all this. All right, so there we go, and that's really cool. Now I'm going to tell you something interesting. Okay, you look at the stars; they look kind of close together, don't they? That's actually a function of the camera, all right? And it's a function of your eyes when you're looking with your eyes. I gotta say hi to Isabella. Hi, Isabella. It's so nice to see you. I want to say hi to everybody else too, and then we'll come back to Albireo. I want to just welcome everybody. Sally Forth was first. Ta-da, you win. And then Michael Hedrick was next. Kathy Messick is with us. Daisy and Zoe Amethyst. How are you guys? And then Mindforked. Hey, Chris. How are you? Nice to see you. Ronald, ERRT Radio is fantastic. Listen to his radio station on ERRT Radio on Mixler, I believe. He'll correct me if I'm wrong. And Tim F. Nice to see you. Harvey's with us. HRVY. And then we have... let's see who else. Oh, Jessica's with us. Hi, Jess. Fantasy's with us, of course. I was talking to him earlier. The Goblin is with us. And Donald Kunzer's here with us again. Really nice. And Starsium. Hey, man, how you doing? I think that's pretty cool. Starsium says, for those in northern U.S. and Europe, you have a possible chance of seeing the northern lights. The KP index is 6. That's a flux index from the sun. The higher it is, the more high the chances. And he says, I'm near Detroit. I wish I were in northern Michigan right now, the Upper Peninsula. Yeah. Very cool. Thank you for that, Starsium. Very good to have you tell everybody. And Laura Newbert's with us. Hey, Laura. How are you? I haven't talked to you in a long time. I've got to catch up with you at some point, Laura. And then we have Stuffy again with us from Hickory, North Carolina. Nice to see you. And James Dugan from Australia. How you doing? Good eye to you. Let's see who else is here with us tonight. It's nice. We got a good all-star crew. You're the important ones. Curtis Horn's with us too. Hey, Curtis. How are you? Curtis, let me know in the chat if you've got anything new research-wise that I can pass on. Let's see. I think we're caught up. Isabella, of course. Isabella says, I see Orion in the morning. That is so true, Isabella. Yeah, we do. And Orion, early in the morning, you can see it rising. And it'll be so much fun to look at Orion with this telescope and with the Benson telescope at the same time. That's going to be cool. Yeah. Let's see. And Ronald says, when I get my Starlink installed. I thought you already had it installed, Ronald. Okay. And then we have Star Traveler 29 with us. How you doing? Good to see you. Isabella, how have you been? It's so nice to see you here. Everybody knows Isabella. She's like a superstar with a Skytra live stream. Done so much for us. And we have Chevon Cox. How are you? Is that Kevin? Chevon? How do you pronounce that? Chevon? Kevin? That's a cool spelling for Kevin if it is. Or is it just Chevon? I mean, you'll correct me. You'll tell me how to pronounce it. I like getting things right. All right, so I'm now going to bring back our background stars and all this information back here so you can see. Even here in Cygnus, you can see some dark clouds. There's some dark areas here. These are all typical dark clouds. I'll color correct to give our background the proper tuning. There we go. So we have Milky Way and soft red emission nebulae here. A lot of cool stuff. And I will I'll move on. I just wanted you to see that. I'll save it. All right, here. Did I actually? Yeah, I did. I said that the right thing. Okay, and I'll save it exactly as seen. And we're done with that. So now we're at the end of Cygnus the Swan, and we saw some really cool stars. That pair of stars is beautiful. If you guys get a new telescope like Kathy Messick just did, Kathy, look at Albireo before the season is over, and you will be stunned. Yeah. Oh, Siobhan. Okay, thank you, Siobhan. Siobhan Cox, thank you so much. I like getting people's names correct, and, no one gets mad at you if you ask them. It's a sign of respect. All right, so let's go here. Now, keep in mind that we have been fighting an issue with this telescope, and let's hope that it doesn't do anything to us that embarrasses us. But if it does, it does. Okay, so from the end star here, we're going to go to the middle star in Cygnus. That's called Sadr, S-A-D-R. There it is right there. And we're going to look at an unbelievably beautiful and dense nebular region right here. It's not a big square. That's all that was just shown here. These are very low resolution images. So we're going to go to Sadr first, okay, if it'll get there. And from there, we're going to actually, yeah, it's going there now. And then from there, we're going to actually move out to the other stars and the other regions. There's Sadr right there. All right. Now, you don't see anything here, okay, but it's here. We have a beautiful set of nebulae, and I got to take Sadr and put it up here so we can see this, because that's where this nebula is. It's a beautiful nebula. We're going to go to the east a little bit. Okay, here we go. Sadr is not the subject of our view right now. All right. Curtis Horn, you said something about, what'd you say? You figured out you forget. Oh, good news or bad news. Last month, Jim Wood passed away, at 84. Thank you for that. It's bad news, obviously. But the good news is I figured out inertia. Oh, we were talking about that before. Provisional patents and physics paper. Excellent, Curtis. I can't wait to read this and look at it with you. Curtis, I'm going to be at Contact in the Desert, I think, again. They've been having me come back each year. So if you're going to be in Palm Springs, California, up in May or so, maybe we'll get a chance. Next month, I'm in Nova Scotia at the Shag Harbor event. So if any of you are going to be there, come say hi to me. Okay? All right. So we got this here is the nebula. And you can kind of just see it, can't you? It's sort of there. All right. Let me just drop this down a little bit. All right. This is going to be a 25-second photo. And we're guiding right now. And we're going to come out of this. It's a beautiful night out there, so I'm hopeful that it's going to produce no errors with our guiding. So there's Albireo again. You can look at that image until the next one comes in to overlay it. Fantasy's correct. Yep. Sadr, it says S-A-D-R, but that's okay. Means, look at that. Oh, we started this before the guiding had fully started, so we're going to do it again. Sadr means chest, and it's actually the center, the chest of the swan. That is correct. Very cool. Yeah. Oh, yeah, it's going to be end of May is when contact is, and it's pretty warm there. Okay, we actually gotten that the second time, so we're going to try again. I mean, we do have this giant flag sticking up in the observatory, so if there's wind, it's going to kind of blow it around a little bit, and that's a problem. But once it starts, we'll make sure we get all the good shots. Let's see what we got. There we go. Satellite came through. Now this is the it's called the Gamma Cygni Nebula, which is this. Gamma, Greek letter, is used in astronomy to delineate the brightest stars in a constellation. So you have alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pi, rho, sigma, tau, upsilon, phi, keep, psi, and omega. Okay. Yeah, we learned the Greek alphabet. It's like rolling off a log. And the brightest stars are labeled with those Greek letters. So alpha is the star Deneb in Cygnus. Beta is I think it's Albireo. And then gamma is Sadr right here. Albireo is actually 2 stars. Okay. And as you saw, and those 2 stars are the ones that actually are actually adding to the brightness of the star, the main star. So that's what we see. Okay, let's come over here and let's start to darken up our background here, right up that curve. Okay, look at that. So we have red, green, and blue curves here, RGB. Oh, come on, man. But it'll overlay, as you can see, it's going to overlay them. The RGB curves, and that's the black level. So if we pull it out, we introduce brightness that really isn't there. Okay, and so it's kind of like a contrasty type thing. So you write up the white curve is the average of all the curves in here, the red, green, and blue. This is the mid-level curve. You pull it down and you soften detail, but you get rid of noise. Okay, pull it in and you get increasingly more noise. So it's a balance. It's a happy medium. You move it in and you stop for a while. So right now, this image doesn't support this type of view because you see noise in here. Okay, I can get rid of some of that noise by coming in here and doing color noise reduction. So kind of watch right here. Watch what happens when I do that. So here I do it, and watch, boom. See, noise goes away, and it looks kind of good. We can also add an unsharp mask, and if we add that, and I have it on a relatively low, it's going to show you more details in here. You see that? You see more detail in here. All right. So, but what we do is we have to take that mid-level down a little bit to soften the noise, and let the image data catch up to remove the noise. And that data is removed by adding more numbers here in the stack. If we stack more images, then all the noise in the black part is averaged out, and so we don't have noise. The same thing in the bright areas. So it's pretty cool. Hey Sam S, hello Hein Sherry, how are you? Yeah, again, Daryl's not with us tonight. I actually, again, I didn't contact him tonight because a couple days ago he wasn't feeling good, and I just didn't want to make him feel bad if he couldn't join. So I'll check with him tomorrow, see how he's doing. Curtis is giving me another update. Completing Einstein's program. Curtis Horn is a very smart guy, by the way. He might have guessed by looking at what he writes. So I really admire that guy. He's really doing the good work, man. All right. Curtis Horn will be easy to make a powerful impulse drive. Well, the only thing you have to do there, Star Traveler, is identify and define what impulse drive means. Look at this nebula. Isn't that gorgeous? Now, as we talked about yesterday in part 2 of our Milky Way tour, you can see these dark clouds here. These are sitting over the top of the bright nebula behind it. Okay? That's how that's working. These are in front. So they're obscuring what's behind it. So you can see this side and this side are actually connected, but this dark rift is in front of it. And you can't see the rest, but you've got the bright side here and the bright side there, if you look at me in the lower left here. Okay? And this dark rift is blocking you from seeing the bright nebula that's in here. That's kind of cool. Again, these halos are an artifact of our observing system. Yeah, we'll get Daryl back in here, James Dugan. All right, so let's zoom in a little bit in one area that's really interesting. Okay, if you look in here, look at that convoluted region. I'm going to try and push this a little bit. It might be a little grainy, but we'll get to see a little more detail. That's actually okay. And then I can pull this in just a bit on our curve, darken up just a little, then back that off a little more. Yeah, the Gamma Cygni Nebula has always been a nebula that I kind of gloss over, but there's so much going on here, and what you're missing too is down here in this region where I'm not looking right now with the field of view. There's another nebula that's really fascinating. Let me show it to you. We won't be looking at that tonight, but here's the Gamma Cygni Nebula, right? And right now we're looking right here. Okay, actually, let me show you where we're looking. Here it is. Okay. Let's just identify this. Okay. And we have a red square, which is our field of view. Okay, that's the red square. You can just see it right there. Okay. It's 3 full moons across and 2 full moons tall, so it's looking at a large swath of nebula. Okay. And so down below, it's actually more down below here, is another element to this nebula, which is really fascinating. You know? But from here, let's see, we've got 15. That's actually pretty good. I want to make sure that we label this correctly, because we didn't. Here we go. And I'm going to do that and say set the target name, and it's Gamma Cygni, and that is going to be, that's IC318. That's the name of the nebula. Okay, that means IC is one of the catalogs. There's many catalogs in astronomy. IC stands for Index Catalog. I've used the Index Catalog, the New General Catalog, NGC, Sharp List catalogs, Lund catalogs, you know, Barnard catalogs for dark nebulae. Okay, like this little dark thing right here is probably a Barnard object in the Barnard catalog, which is all dark nebulae are categorized, and it's really cool. Hi Otto, how you doing? Hey Larry. Let's say no, it's not Larry. That was Donald Kunzer writing about Larry Niven. Sorry. Wow. Yeah. Okay. So let's get rid of that right there. Let's save this. All right. Save it directly as seen. Save it exactly as seen. And let's come out of this and move on to another object. Because so far we looked at Albireo, the N star. Now we move to the middle star, Satyr, and looked at the nebula associated with Satyr. Right? And now we're going to look at another nebula, which is, of course, a showpiece in Cygnus. See, there's that thing. Now maybe we should look at this. We should probably look at this, because there's actually some real interest in this. So before we go there, let's just move up to this. The telescope won't have to move much. All right. And we should see these 2 stars in there. Actually, I want this star. Hipparchus, let's do that one. Put us there. All right. So you can see the nebula right here. Look at that. Holy cow. Okay, so now we can do this. And now we have that star I was telling you about. Let me just make sure it identifies it properly. There it is, Hipparchus 100736. I believe that's the one we're looking at right there. 100736, yep. Okay, so we're right in the middle of this really pretty nebula. So we're going to check this out just to show you another type of nebula. This will do 30 seconds on. And our speed is 250, our sensitivity. All right. All right, so there we go. Let's do this now. There we are. Okay, that's there. Okay. And let's open up our live stack on this. And I actually, yep, that's got to go. That's a mistake there. Okay, drop that down. This is what we previously had. And I'm going to do this nearby thing again. There we go. Look at that nebula. And I wanted to show you this because there's a reflection nebula, blue nebula in here with a red nebula. I guess I could have gone over a little bit more. So let me actually do that. Why? Because I just want it to be perfect. So we're going to move this over a little bit. All right. here we go. All right. All right, so I'm going to move this over to about here. So that means moving to the west. I want to thank you guys for all coming out here. It's a lot of fun. Hey, Kurt. Kurt's with us. Kurt W75. Nice to see you, brother. Yeah. And so now, we are pretty much where I wanted to be. So what I'll do now is we'll come back and do a 35-second shot like I mentioned. We'll do it again. Like this. We're off and running. We can start our stack. Alright. And that's the one that's going to be more centered now. But that star is going to be here. So we'll clear this. Although it'd get overwritten, but we don't need to do that. Cosmic Ray's with us. Hi, Cosmic Ray. What's up? And Dean Boss the Door. Nice to see you, man. You've been a while since we heard from you. Same with you, Cosmic Ray. Okay, so the stack's been reset for this guy here, and we're going to, as soon as this comes in, all right, we're going to get the ID here, and it's going to be this a reflection nebula, and that's going to be our target name. All right. You notice how when we only have one, it's kind of noisy looking. As soon as you double the number of frames you take, you have the noise. And that can be a little or a lot. So from 1 frame to 2 makes a huge difference. So run 1 right now. So watch now. Watch how this gets better in just a second. Ready? Here it comes. Boom. Look at that. See how this looks much nicer? We've cut the noise in half. And with 2 frames, when we get to 4, we'll cut the noise in half again. So every doubling of the number of frames cuts the noise in half. It's a rough rule of thumb. But this is a beautiful nebula because we've got this reflection nebula here, which is just the dust scattering starlight and scattering the blue part of the star spectrum only. That's what's happening here in that area. So that's why we see that. All right. And then here is just the hydrogen being ionized as normal. All right. So what I'll do is let's just drop this down, okay, and let's move the telescope out of the way for just a minute. And let's zoom in and just watch this develop. If you can read the bottom of the screen, make sure you're in 1080p so you can read the bottom of the screen. We have 3 stacked images here and none were ignored or passed by. The temperature of the cooler is that means the temperature of the sensor is minus 15 degrees Celsius. That's cold. Yep. And Rascally says, I saw the Lobster Nebula today in pictures. Very cool. Yeah, we took an image of the Lobster Nebula not too long ago, actually. Let me just do an adjustment here. Let me do a color correction. It's a subtle one. And then I'm going to drop this down just a little to soften the noise a tad. Oh, look at that. This is a really, really beautiful object. Yeah. So again, you notice there's some dust here. Now, with the Benson scope, remember our field of view in Benson is actually a lot smaller. So when we actually look in Benson, we're going to be seeing a view that's sort of like about this. It's a square field of view. So it's about that size. So we'll be able to zoom in on this and just look at this. And we have a sensor that's almost 2.5 times more sensitive, more pixels in that same area. So we'll be able to see a ton more information as well. Now, right now, Benson's cloudy, so if it wasn't, we'd have the other telescope open as well tonight, and we'd be doing this exact thing. Yep. Absolutely. Cosmic Ray saying, what's the status of spectrograph for the Benson scope? I have bought certain components. I'm going back out in October. There's two things I'm going to do when we go out in October. I'm going to take this scope and convert it to a different mount, an equatorial mount, add a pier segment that's going to lift it higher in the building. So we won't be limited by the building anymore when it comes to trying to look at objects. Now, generally in astronomy, if I was doing research, I would not observe below 40 or 45 degrees in the sky. You just have everything kind of above you. And that's to limit what's called the air mass that you're looking through. We can correct it as long as we take samples, but it's not not something that we would actually want to do if we're doing real astronomy research. But for doing this public outreach, which is what I am an outreach astronomer, as you know, then this is fine. Stacy Vornbrook, how are you? Vornbrock, nice to see you. Thank you for joining us. And she says, breakthrough performance, absolutely beautiful. Thank you. Oh, you're more than welcome. Subscribe, if you will. Please like and subscribe. Please hit the thumbs up. The more people that join us, the sooner we can, do really good things. Now I'm gonna bring this in a little more, darken up the background a bit. All right, there it is. Okay, and now we're gonna be able to catch this. You see all this dark material is again blocking what's behind it, and it's that dust that is being illuminated. It's illuminated by the starlight here, and the starlight is being scattered. Only the blue piece, and it's blue for the same reason our sky is blue. I've said this 1,000 times. It's scattering the blue light from the stars. Remember, the stars are red, orange, yellow, green, blue, indigo, and violet. Roy G. Biv. And so the blue light gets scattered very nicely by small dust grains and by atmospheric molecules in our atmosphere. So we have the same process happening to create this reflection nebula as creates our blue sky. And that's kind of cool. So these are common colors in the universe. Blue like this, red like this. We also have ionized oxygen, which shows up as a teal blue. We've seen that with the Dumbbell Nebula. It's really something, All right, we've got 10 frames stacked here. We'll go a few more. And remember, once again, every one of these photos are available at skytourlive.org for free. You can download them and put them on your desktop, do whatever you like with them. Cosmic Ray says, so you need a second scope in Benson for the spectrograph. Yes, I'm going to use a second. I was going to do, and I may still do this, I want the possibility of using my filter wheel. So what I might do is work out a turret head for that telescope so I can rotate the spectrograph into the system and rotate it out to do the stuff we're doing now. Rotate it in, get a spectrum of this nebula, do the spectrum, rotate it out. So, I'm working on that. An extra telescope is an extra thing to do, an extra headache. But you know what? If we get the support and maybe more grants or support from our viewers, then we can actually do all of this. And we do have another possibility opening up, as I might have mentioned, for a third telescope site, and that's going to be in the San Luis Valley in Colorado if all goes well. And that's pretty much the darkest part of the United States is in the San Luis Valley in this particular location. So it's really, really something. And it's also at 7,000 feet in altitude. I did a sky watch out there about 3 weekends ago, and did a lecture, and then did that Skywatch, and boy, people really enjoyed that. So hopefully we'll get to do that. And again, we're all doing it because you guys help us out. And as you know, I don't take a dime for this. I don't get any money from this at all. Everybody involved, me, Marianne, and Tara, the three of us in the nonprofit, we don't take any money. We actually put in money. because we believe in the mission, and that's to allow and give free science education to people. And if you can be turned on to this stuff, I can tell you it's going to be amazing. Laura Newbert says, "Oh, is that mean you're Daryl?" And the answer to that is Daryl is several hours away. He's actually about 2 hours away. So technically, yes. Cosmic Ray says, "Is Asterion providing equipment?" Asterion isn't providing equipment. Asterion gave us a grant, a small grant, to actually buy the equipment. And so we're going to do that. I've already bought some of the equipment now, but I can't use it until the spectrograph comes in. It's coming from France because they're the only ones that make it. And so we have to wait. And with tariffs and the other things going on, it's kind of slowed the process a little. But we're still heading down that path. Because I'd like to be able to show you guys when we look at certain stars, we look at like a supernova. I'd like to be able to show you what's going on in the supernova, what it's giving off, And like, for instance, we could use it to look at Uranus and Neptune and Jupiter and see the lines of the gases in the atmosphere and identify methane and other gases in the atmosphere of the planets, using the spectrograph. It's so cool. It's a really, really, really cool thing. The Ambassador says, "Beautiful image." Yeah, it is a beautiful image. And again, the name is here. It's New General Catalog Number 6914. How romantic. How descriptive. Okay. But it's beautiful. And we've got 17 stacked. We're going to go to 20 with this. I'm going to redock this here. So we're going to bring that back. Okay. And then I'm also going to bring the telescope back. Okay, it almost missed my hand. Okay, and so this is just an example of the Cygnus clouds that we see. Keep in mind that just up north of it here, toward the top of the screen, is the nebula we took a picture of just moments ago. All right, but I wanted to show you this one in particular because we had this gorgeous blue reflection nebula in it. And it gives a chance to teach people about it, And Rascally says, Benson was a 70s TV show starring Robert Guillaume. Yeah, that's correct. Another useless fact. Yeah. And you know what? There's one episode I recall of Benson where there was a guy, I think he was, I forget what he was, but he was at the airport and he was trying to get Benson, and he basically says, Ben von Bova, Ben von Bova, and he has a sign that says Ben von Bova. Now, I don't remember what his last name was in the show, but he got the name all wrong. So it was a bit of comedy. It was funny as heck. I remember that. Well, again, another useless memory, right? Yep. So cool. Laura asks a really good question. What effect would 3i Atlas have on Mars if they were to collide? Well, so they won't, but let's talk about that. What would happen theoretically? Well, 3i Atlas, we'd have to get a better idea of how big it is. We don't really know. It's anywhere from 0.2 of a mile in size to about 25 miles in size, the nucleus. All right. And so that nucleus, at a quarter mile across, could do some damage depending on the speed it strikes the Martian atmosphere with, which is very little. So it would get all the way to the ground and make a giant crater. But if it's 25 miles in diameter, well then it would probably put up a dust pall, a dust cloud around Mars that would last for years. So it'd be a planet-wide dust storm from this. We had that happen when we had the Chicxulub impact 65 million years ago that killed the dinosaurs. And that we say killed the dinosaurs, and you know what? People say that very flippantly, and even though I just did. But what does it mean? It means it's a cascade of failures to thrive. And so when the asteroid struck off the Yucatan Peninsula, the dinosaurs in that immediate era, of course, were vaporized. But on the other side of the world, they didn't know what happened. They probably didn't even feel anything. Okay? I'm certain they didn't feel anything. And then what happened was they actually noticed that the sky was getting darker and the sun was getting dimmer because this high altitude stratospheric dust circulated through the air currents around the world and started to knock out some of the light. And because of the impact being so big, again, it was like a 10 mile diameter impactor, it blocked out a lot of the sun, and near the site, it turned day into night, and farther away around the world, it turned the day into dusk, at the very least. And so that process was, hey, Daryl's here. Hey, Daryl, how you feeling, man? I didn't call you because I didn't want to make you feel bad if you couldn't join. But I'm glad you're here. So that process with that dust in the air caused the plants to die, and the plant eaters died shortly thereafter, within a few weeks. And then we lost the plant eaters, and thus the the creatures that fed on the plant eaters. All right, so the theropods, the meat eaters, they ended up dying too. So it was like a cascade. All right. Oh, sorry, Daryl. I hear you're still sick. I see. So that led to the extinction. So it didn't happen immediately. That's the misconception. It happened over a series of weeks to months. It didn't take long for the plant eaters to die when their plants died when the sun, went in. And of course, they struggled to find food naturally. And some of them could find some, and others couldn't find any, and they died first, etc., etc. So anyway, 25 shots here is good. This is a beautiful object, NGC 6914. It's a rich nebular region with ionized hydrogen and this beautiful reflection nebula. Look at the cloudy structure. Look at that. It's so beautiful in there. All right. So now if you go to skytourlive.org, these images are provided to you free. This is the image you can get right now. That's right there. I just saved that to the server. You can go up there to skytourlive.org, scroll down, and it says, I want cool pictures. Read the instructions, go there, go into the directory, download this picture, and it's yours. So, as I said, I don't think there's anybody doing this. Providing an astronomy education and then providing you with the pictures we take for free. Everybody wants something. Everybody wants $1 for this or that. And I don't even take money for this. Okay, so that picture is beautiful. And now what I'm going to do is come back here. And let's go to the next object. That was a really neat object, 6914. All right. And you can just barely see where it is in here. You can just barely see that. All right. Okay. Now, let's back out a little bit. There we are. All right, let me come back now to our... Hey, Dan Clark's with us again. How you doing, Dan? I know Dan for many years. All right, and now let's back out of this because we are here right now, and we're actually going to come down here. Now, we shot the Pelican Nebula the other night, but what I'm going to do now is we're going to shoot the Cygnus Wall, which is down here. The Cygnus Wall is beautiful. And to do that, I just have to have the telescope go to this one location. And we're going to have it go... Actually, I can make it go to a particular star down here. Okay, now we're going to tell it to go here. Let's make sure that it's going to go there without causing us any problems. It should just move slightly. Here it is. We got our slight motion. There we go. And our focus should still be good. I'm going to make sure. Looks it. All right, let's get a target view on our name here. See where we are. So we're very close. Hipparchus 103341. Let's go in here and look at nearby stars. See 103341. There it is. So this is where we're centered right now, roughly. Okay. So that means here's our view. You can barely see the red outline here, but it's there. So we're right here. So this is a good place to be. All right. And so we'll come out of this And it's upside down. The telescope's upside down backwards. All right. So I believe that I'm going to just do a quick 20-second shot to make sure, but I believe that the Cygnus Wall should be in this image. It's probably right here. If it is, I'm going to move this down a little bit. But let's see. We're not going to stack it because we don't have to. Not yet. Yep. So this is 3 nights in a row, guys. Oh yeah, look at that. Wow. Okay, so we are actually going to move this over. We're actually not quite where we want to be. And that's all right. All right, so we're going to move this star over to here. All right, so let's do that. We're going to go to the east a little bit. Okay. All right. Yeah, there we go. And let's bring this up. Like that. Like this. Maybe I'm going to actually go back to the west slightly and put that in the upper left. That's okay. All right. Yeah. We had a roof issue, as I mentioned last night, with Benson. It's fixed, but it's cloudy there now. But the roof issue made the roof close too far past the edge, and it sheared off one of our cameras. Just sheared it right off. So it's sitting on the table inside the observatory, thanks to our technician who goes out there to help us. That's Frank Lopez. All right, this should be good. So I bought another camera, another bracket, and Glenn, who lives in Benson, is going to be going out there to install it later this week. Okay, this will be another 30-second shot because there's a lot of beautiful dark data in here. Daryl says it's finally clear there. Nice, man. Hey, Daryl, thanks for coming in. I know you're not. I know you're not feeling well still, but very nice to see you come in. All right, there we go. So we're gonna go into that deep sky mode now, and we'll be good. We're gonna live stack it too. So that's the image we just took. I'll leave it there because it'll be overwritten by the new image of what's called the Cygnus Wall. And the Cygnus Wall is a famous location in a region of Cygnus where we have the nebula called the North American Nebula. And let's see how this looks. Oh, look at that. I actually have to bring us down a little bit. That fooled me. That little part right there fooled me. Okay, so the wall's kind of out here. Part of the wall's out there. So let me fix that real fast, and then we'll bring that back. Very good, very good, very good. All right, so now I'm gonna do this. And go eastward a little. Like this. Move it over. You can see the wall right here, actually. And I'm gonna go up a little more north here, just by a tiny bit. Okay, I think that will probably be good, but I'm gonna, it's hard. You want to fit everything in, but you can't fit everything in, All right, we'll go here, and we'll see. We should have a nice spire here, which is kind of cool. All right, so now, actually, I might be able to do this here. Okay, we're guiding. And let's go back to that low light stack mode so you can see. Right, so what I've done is I've moved this area down here. All right, look at that dark dust though, huh? Just in one exposure. Check that out. This is feathered in. So I move that down and over a little bit. So we'll see where it lives. We'll see where it lives when we're done. Kathy Messick says she's under heavy clouds in Seattle, hoping for clear skies when Saturn goes prime. You'll get a clear sky. Saturn is going to stay prime for, a little bit of time. There we go. Look at that. And that's perfect, because that's what I wanted to show you, was this dark dust that's, again, in our foreground, blocking the nebula behind it, which is this nebula, that little piece, and that little piece. Those are behind this black dust. So if you could take this black dust out, we'd see a large sheet of nebula right here. Look at that. Wow. That's beautiful. And we're going to call this the Cygnus Wall. That's the Cygnus Wall. All right. Yeah, and as we... now in Benson, just again to give you a good feel, the Benson scope, the size of the scope field is like this. Okay, it's square. Shows about that size of a field. So much smaller than this, but it has far more sensor pixels in that square. So we see a lot of detail within this segment. So we're going to be showing you that too once we have our clear skies back again in Benson. Look at that. All right, so we'll wait this out a little bit. C&D boy, how you doing? Hey, I gotta tell you, thanks for putting up links for us the other day. That was very kind of you yesterday, and the day before, I think. Yeah. So we have 4 images here, and I'm gonna show you what happens. We're gonna drop down this mid-level. It's gonna soften things, but you notice it's gonna clear a lot of the noise. And so what happens is, as you get more and more exposures, you can bring this value in, because you don't end up with a lot of the noise like that. JSEO. Wow, what an image. I know, huh? And this is right over your head if you're out in the west right now, southwest. It's right over your head at 9 o'clock at night, and you don't even know it's there. Unless you're an astronomer. Really pretty. I also wanted to mention that ERT Radio, Ronald, is going to be setting up a telescope in his backyard. And he moved from his home in Minnesota to a new home in Benson. So he's now 6 minutes from the Benson Observatory. Not this one. The Sonoran is going to be 3.5 hours or more for him. So he can't go there. Yeah. Star Traveler 29. I got some time on Phantom of the Opera Nebula last night. Very faint. Wonder how well your scope can pick it up. I don't know it by that name. What's its number or location? Do you know? All right, so I'll pull this in a little bit. We're up to 7. See those really, really delicate filaments? Now, you got to understand that everything out there is in motion. Everything's moving, just like clouds in the sky. It's just much slower because this is many light years in size, for instance. Okay, this is many light years in length. So the motions take minimally like 10 to 50,000 years to even be slightly noticed, depending on how fast they're actually moving. And Dean Basador says something really interesting. He says it looks windblown. You're right, and you're absolutely correct. There's stellar winds that are pushing these. And what is stellar wind? Stellar wind is loose protons and electrons streaming away from the star. Our sun does them. Okay, and when you have a loose proton, it's a +1 charge. A loose electron is a -1 charge. So when they come into the atmosphere, they're charged, and charged particles interact okay, with our magnetic field and cause electrical currents in our upper atmosphere. And when you have a lot of them, you get a lot of electrical currents, and thus they create emissions in the molecules in the upper atmosphere called auroras. And that's why auroras happen, because these charged particles from the sun spiral in by our north poles and south poles. So we get the aurora borealis for the north and aurora australis for the south. I'm happy I don't live far north, and I'll tell you why. I don't think I'd like to see auroras every single night when I'm trying to take pictures like this. Okay? So I'm happy that I don't live far north. Oh, SH2-173. Wait a minute. That's not the Gamma Cast Nebula, is it, Daryl? Because Gamma Cast Nebula looks beautiful in this telescope, and I'm just anxious to show that when it comes up. That actually sounds kind of familiar. Yeah, so look at that. 11 shots, and I mean, it's just worth listening, letting the music play when you hear this. Welcome to the starry night of Cygnus and the North American Nebula. All the happy details. Yeah, the Cygnus Wall is a favorite. Little zoom. Beautiful. That's light years long right there. And it's here in the dark where life may begin. Life begins in the dark. Thank you, Cosmic Ray, for that clarification. This is live, folks. All live. By doing this, you can see how this is clearly in front of the bright nebula behind it. It's literally washing over it from stellar winds. Absolutely beautiful. So that is actually beautiful, and although I gave my voice a little bit of a rest. Yeah, Jessica says, difficult to choose which nebula is my favorite. I do love the Horsehead Nebula. Yes, and in the Benson scope, it shows up very big, And in this scope, it's small, but you can see the whole surrounding. This telescope is good for wide field views. And this telescope is the stunner. It's the one that just introduces you to a region and says, wow, look at all the beautiful objects in this region. Okay? And I'm going to be very careful about how much dark I show, because this stuff is actually brownish black. It's not fully dark. And if we let it do what it wants to do, you'll see where it goes. Okay, it's going to pull it down a lot, which is fine. It's kind of reducing the noise. Alright, this is 20 shots, and I'm going to save that. And then I'm going to pull this almost to the peak, darken it up a little, and bring it over here just to increase the brightness a little, and save it again. Once we get to 21, there we are. Save exactly as seen. Hey Prowl, how you doing? Cosmic Ray asks, and Daryl answered, what excited gas produces white light? Well, it's the function of the camera sensor. You're looking at a subtle red glow, but because we're exposing it for so long, it saturates a little more and looks brighter. So white, as Daryl points out, is really a reddish glow. Alright, and I mean, I used to take pictures of this in black and white, and this is what it looked like. Alright, let it just right there. That was what I took pictures of when I was taking pictures of it in the past. Not because we didn't have color, of course we had color, but the black and white was the most popular way to do it in astronomy. And not only that, we would do that, but then we'd actually do this to it. We'd actually turn it into a negative. So that's what we actually worked with in astronomy, so you can see more details by looking at that. You know, so that's what we looked at, black and white like that, and the color wasn't there in our negatives. Okay, we used black and white plates, but what we found was you could actually move and adjust the processing to show more detail. And so here you can bring this way in and see more detail in there. Look at that. So now you see more detail in here than you did normally. Now if we come out of this same view doesn't look as helpful. Okay, all right, and if we look at it in color, all right, then you can see that it looks a little bit washed out. But as far as a negative image goes, that's very helpful to us, you know, in astronomy, and we use that to do calculations and measurements. And it was the inverted images that we always saw. Stars were always black in research. They're always black to us because we'd invert all the images and use the actual negative images. Well, thank you, C&D, for putting up that link. Mundus Flint, howdy, howdy, howdy. Nice to see you again. Very nice. Alright, so here's 26 shots. I think that's pretty good for the Cygnus Wall, so we're going to save it. Save it exactly as seen. And for those latecomers, I did address the 3i Atlas. It's in Libra right now, and Libra is almost set, so it's kind of hard to catch it. And this telescope is the wrong telescope for that. The Benson telescope is better. I did capture it already with the Benson scope. You may have seen my Facebook post showing the James Webb view of it. It has a tail now. It's sporting a tail, and there's a lot of cyanogen that's being seen. I have a theory as to why we see a lot of carbon dioxide. I think that based on where it formed in the galactic disk, it probably ended up capturing a lot of carbon dioxide ice on its surface. and it depends where in the galactic disk it formed. And so that carbon dioxide ice was sublimating and forming a carbon dioxide cloud around the nucleus and the coma, the area around the nucleus. And I think that's what caused it. Let me just add this last bit of touch here. There we go. Okay, I'll save one more time, and then we're done with the Cygnus Wall. Remember, this image is completely available to you, and the image you're going to get is this one right here. This is available to you for free. It's up at skytourlive.org. Follow the directions, and you scroll down and see I want cool pictures. It will direct you right to the location of our server, where you can actually then go through and look at 4.5 years worth of images. So it's pretty cool. Laura Newbert says she sees pulsing, and that's true. That's actually a function of the remote access tool we're using. There's not actually any pulsing going on. Unfortunately, that's an artifact, and I'm talking to the maker of the software to try and get rid of that. So we're working on that. Okay, so at 30, we'll save it the last time and then move to another object. I think we're getting just long enough to capture some cool things. Hard to say goodbye to this. Let's take one more look inside. Let's go through. Look at that. Look at that beautiful detail in there. Look at this little swirly whirly. Okay. We have an object right there. Looks like a gravitational condensation, which is kind of neat. That's something that indicates we're probably looking at a potential planetary formation in there. Okay, so right there inside that square we might have a system forming. We got another one right here. Okay, it's right inside that little box. We got a bunch of them over here. So there's a lot going on, and again, these are many light years apart. So many light years apart. So it's unbelievable. All right. So that said, we're done here. I'm gonna just do one last save because we are now 3 more in, and the more we get, the better the image looks. Okay, now what I'll do is get out of here before it keeps getting more images, and I have to save them anyway. Yeah, Cosmic Ray, I already went through that. I told people how the scattering works to make the blue, but thank you. Thank you. And now let's go here and look. Let's back out. Now, we're right near a few other really cool objects. Okay. Let's go to this one. This is neat. This one shows us a fascinating view. Let me actually make sure that we go there. All right. And then do this. All right. So now we can come back and go to the Cocoon Nebula. And let's hope that the telescope goes fine. It looks like it is. That's about the right direction. As I said, we've been fighting with a problem with the telescope, but so far, it's been working just so fine. Okay, it looks like the cocoon is right there. Let's see what it says. Indeed it is. Okay, good. So, I'm going to move this down by going up north, and then we're going to go east a little bit. Actually, we're going to move a little bit more because I want to show you something really interesting with this. This is an example of a dark nebula where a star formed within the dark nebula. And the star was hot enough to ionize hydrogen around it because Hydrogen is the most plentiful element in the whole universe, as we've talked about many times. And so it ionized a spherical region around it. And you see this beautiful region. You can almost see it right here. It looks sort of pinkish right here. And you can see the trailing dark nebula out here, which you'll see in just a moment. I'll move over just a little bit more to the left so you can actually see a little more of that trailing darkness. Okay, but you can almost tell where that darkness is because you can see where the lack of stars are here. All right? So we're going to go, and this time we're going to do a 40-second shot. Now you might say, oh no, 40 seconds. Well, we need to do that because 40 seconds is going to pick up some details that we may have not seen before. So we're going, it'll go fast. All right, so let's come in and you'll see our last image that we took of the Cygnus Wall, hopefully. We come in, actually, let me do that first. Okay, that's going to go away now. No problem. All right, so we are now in the northern part of the sky, looking at this. Laura, nice to see you. I know you got work tomorrow. Thank you so much for coming out. It's 12:24 here in the morning. And this will be, like I said, this is part 3 of our Milky Way tour. We went all the way from southern Sagittarius all the way up to here. And we're still not done because we have Cassiopeia right here. Yeah, there's our Cocoon Nebula. Let me color correct it. It'll end up looking like you expect. And now you see that dark material right here. And we'll move this black level up almost near the peak for now. Okay. And then we'll move this mid-level down to kind of soften the noise for a moment. There we go. So now you can see, and you'll see that we have this red in here, but you'll notice there are hints of blue. And as Cosmic Ray pointed out, and as I pointed out, that is the scattering of the blue light of the stars, or this star in particular, inside where this nebula formed, or where this star formed, and that's the star that formed inside there. And it's responsible for lighting this up. And it kind of shows you something very important, though. What it's showing you is how far away from the star the radiation, the ultraviolet radiation, can go before it stops ionizing the hydrogen. The hydrogen doesn't stop here. It continues all out throughout all of here. But that's the ionization radius for that particular star. If it was hotter and bluer, well, then that star ionization radius would be much further out too. Let's actually go back to this for a minute. It won't block our view. And let's go look at the cocoon again. And let's see if we can get the spectral type of that star. Maybe, maybe not. Yeah, no, it's just a photo. We can't really tell. However, you can see that this image isn't nearly as nicely resolved as this one. We actually have beautiful detail in here. And you see this trail of dark. So this was a dark nebula. And when that star formed in there and winked on, it began to ionize the hydrogen also throughout here. And so we ended up seeing this thing getting lit up, roughly spherical. This is a very good example of how ionization looks when you have a relatively isolated star in a mass of relatively uniform hydrogen. And so we actually see that like that. You can actually see it's round, but that's actually a sphere. Okay, the backside we'll never see unless we go there. Hi, and Sherry, good night. I'm glad you had a good time. All right. Okay. Let me see what happened here. Oh, we lost our connection. That's not good. Why would we lose our connection? Yeah, the observatory went down. And I'm waiting to see if it comes back. Well, that's no fun. It's still taking pictures. Well, where it's pointed is in such a position where it won't affect anything. Why is it down? Well, we're going to find out. Hopefully it'll come back. It could be an internet problem. Oh, Benson's down too. And it should be. Okay. Well, that means that we're having an outage at that side of the country. Well, that's no fun. Because that means now that we may or may not come back. But I'm working on seeing whether this will come back or not. Yeah. Not good. But Benson is down too, so I'm going to quickly check on the status of our remote product here and see what's going on. We don't have any rain to worry about. Let's check it out. Alright, let me see what's going on here. Why is it offline? Okay. Please be offline. I don't know why. Alright. I guess we're only... And why is, yeah, Benson's never down, so... Why would that be down too? That signifies an outage in Arizona, for our remote systems. It doesn't signify an outage for just one or the other. But Benson's never down. It doesn't mean that we lost power necessarily, but it means that our telescope system has gone down out there. I'm going to try one other thing. I'm going to try to connect to the Benson Observatory. They'll tell me what's actually happening. I got another way to connect to Benson. And I want to see if it's going to be okay. Oh, it says it's offline. Yeah, it says it's offline. So, we lost Benson at the same time we lost the SkyTour Sonoran. Okay, well, I'm going to wait it out, guys. You can hang on if you want, or I'll just kill the stream and say thanks for coming. I think I'm going to have to. And then I'll wait it out and see if we have it come back. Watch, our luck, it'll come back like minutes after I end. But let's see here. Yeah, I've got no eyes out there. I do have other internet connections, by the way. I see all of your comments as well. All right. Yeah, we do have a solar storm, but telescope is relatively protected electrically, but you never know. I may have to wait until tomorrow for the observatory to come back again. But it comes up at 8 in the morning so that I can actually get in and fix it. I'm not too worried because, like I said, even in the worst case where the telescope, reaches a hard stop at one end of the pier, it's not a major issue for me because I can actually, just continue to change over to the new mount. So the telescope is going to be fine, but, yeah, we're down. All right, guys, well, it was a good night while it lasted now, wasn't it? So I'll just wait it out here. Probably a sleepless night, but, is what it is. Anyway, guys, I'm going to say goodbye to the stream right now. I don't want to because we're doing some cool things, But you know what? There'll be a part 4 now, won't there? All right, part 4, we're going to investigate further north and into Cassiopeia and everything. It'll be really pretty to look at, so we'll do that. Hopefully you guys can join us back then. That'll be, well, I'm trying to do it in consecutive days. you know. But either way, I will talk to you guys soon. Hate to bail, but I've got no choice. Everything went away, you know, and that's terrible. Okay, so you guys have a good night, and I will be talking to you very soon, okay? So, sorry about this. I mean, I could stay on, but what's the point? It's going to be a black screen, you know? I mean, a black screen, unless I go like this and say, well, hi, guys, you know? And that's not exciting to me. I can't imagine it's exciting to you. But that said, waiting. Well, I'll tell you what I'll do. I'll put up the music. And we'll see if we can wait it out. All right, well, guys, I know some of you are going to head out, and I understand. That's totally fine. But Benson is still down, so that signifies a different type of outage. Benson and the Sonoran went down at the same time. That's a major problem. I don't know why. That tells me that when they come back, they should both come back at the same time. And they'll probably be right where they were. You know, the sky, you know, Sonoran is just going to be sitting there looking up at the sky and so forth. So I don't get it. This is actually new. This has never happened before. Never happened before. Yeah, the internet is Starlink in both observatories, Curtis. So if Starlink went down, that explains what happened. And of course, they don't tolerate a Starlink being down for long. We did have a Starlink outage a month ago or so, but that explains why we may have lost something. You're welcome, Namrila. That's fine. This points to a Starlink outage. I have a dual network though out in Benson, but it's not plugged in. I should plug in our wired internet router to the regular internet there, and I don't have that capability at the Sonoran telescope, so I figured I'm not going to use it at the other one. Let me see if I'm going to look up and see if we have a Starlink outage somewhere. Let's see if I can bring up. Let me see if I can bring up something here. All right. Just waiting it out. Well, for those of you waiting, that's nice of you to wait. But let me see here. I'm going to do this. I'm going to hold on a minute here. I'm going to just head to actually I'll head back to here. Just
Stars are
nope,
whispering.
not that. Okay. I'm going to add a window to look at here. And we'll do that. And a new source. And we're gonna the window we're gonna look at is this one? No, not that one. Not that one. We're gonna be looking at this guy. That's the one. Okay. So this is our remote system here, and I don't see. It's not back yet. This has to be a Starlink outage, because this connection, which is live, is not Starlink, and this connection is not Starlink. The connections that are Starlink are this one. Our B-Link is Starlink in one of the observatories, and this one is. So, all right. So it's a Starlink outage. So I gotta look up a Starlink outage map, see if there's such a thing. Let's see. Might be a little soon. Uh-oh. What's this one? When was this? Oh, look at that. September 15th, 12:23 a.m. Okay. Now we know what's wrong. Right there. Major spike. Major outage. All right. That's good news. So we know now what's wrong. And how long will it be before we get it fixed? That's the question. Yeah, we have a total blackout for us. Yeah, let's look at the live outage map. Let's see if someone's reported it already. Oh, Benson is up. Benson just came up. So that means that the Sonoran may follow, because Benson is back. So, oh yeah, look at that. Down in Phoenix, look at that. Yep. Well, I think waiting it out is probably a good idea, because Benson's back up. You can't tell, but I see that it is. So we're gonna wait for the other one. Yeah, there's a big outage in Phoenix right now. Look at that. Yeah. Okay, and Benson's 220 miles away from our Sonoran, so they won't come up at the same time. But with Benson being back, that's actually good news. Alright. Yeah. So, if I come back here, if I put that invisible, there's our Benson view right now. So it's active. But it's cloudy. And the other thing is, our camera out there is not our camera. This is not what it looks like. It's actually it's from a couple days ago. So that camera has to be reset by the owner of the camera, which is one of the astronomers on the mountain. Okay. This is good. Oh, here we are. Ta-da. All right. Look at that. And we're still dutifully capturing. Watch this, guys. The Boomba. Let's do this. Let's get this. Okay, it's back. So we're going to do this. And we won't watch that. And we're going to come back to... There we go. Ta-da. I don't know how many people have remained behind to wait it out. But whoever waited it out, yeah, many people are still here, I hope. So yeah, sorry about that, but we have 25 images taken. Again, it's a 40-second exposure. Look at this now. It's come out beautiful, and we have access again. Yay! I knew. Thank you. Someone suggested looking at the outage map, and when I saw that Benson was out, it was a general outage with Starlink, without a doubt. Big spike. I mean, that was only, what, 10 minutes? So, that's good. All right, here's 26 images. And what we're going to do is, let's see if it knows what this is. It does. The Cocoon Nebula. We'll make that the target. And we'll save the image with the annotation on it so you can see it. And you get the name of it, and you get the right ascension and declination. That's kind of like, it's astronomers' latitude and longitude in the sky, basically. And we'll explain that another time. But that's how we actually will find things in the skies with right ascension and declination. Okay, so now we're going to save this before we can't anymore, if something happens. All right, so we save our astronomical file format, and now we'll save it exactly as seen. There we go. Okay, now we're going to come out of here and move on to something else that I wanted to show you so we can complete our Milky Way tour. Okay, so we're going to go back to our low light mode here. And that will be kind of cool. And I'm going to dump our window that we had before. We don't need that anymore. Well, I can keep it. Doesn't matter. All right, and now I'm going to drop the volume on the music a little bit. Okay, now we come back in here. That's always good. All right, now further north, okay, we have, these lines converge at the North Pole, okay, they're called the equatorial coordinates, and the North Pole is right in there, right? But we have a lot of very interesting stuff here, and this is down here. We have a lot of things down here as well. We have the Bubble Nebula coming up right here. We have Gamma Cast Nebula also, that's coming of age, so to speak. But we're gonna stick up here for now. As I said, maybe it'll be part 4. All right, and what I'll do now is I'm gonna bring up another set of catalogs. Sorry, this is what I'm gonna bring up. And we're going to go here, and we're going to bring up our Barnard catalog, our Sharpless catalog, our Linz Bright Nebula catalog, and our Linz Dark Nebula catalog. And literally, that's more than enough, because we're going to end up with a ton of objects here. As you can see, we almost can't see what we're looking at. All right, but this guy is known as the Lion Nebula. This is neat, and so I want to go look at that. So hopefully we can go check that out. Mars has already set. EAA is Electronic Astronomy Association, is it? I mean, we're doing EAA right now. That's if that's what he's talking about. Curtis is talking about Isabella. Okay, all right, so let's go there and make sure that the telescope wasn't hit by a flare. I believe we got nailed by a solar flare the other day, and actually partially tonight. Earlier it happened. Okay, here is the nebula. You can clearly see this nebula here. And I think what I want to do, wait for it to start guiding. All right, and I'm going to just tweak that so we can see this, and then I'm going to actually refocus, because we've tipped the telescope way back. Temperatures dropped in the building. It's now 23.5 Celsius in the building, and we're a little out of focus here, so I'm going to exaggerate that out of focus nature, and then I'm going to go in and do a refocus event. There we go. Okay, so this will be good. And now okay, so now I'm trying to make sure Benson's still up. Not a problem with Benson. Yeah, and then we're gonna wait for the focus thing to work out here. Yeah, thank you, Curtis. Electronically assisted astronomy. Yeah. Isabella, you may remember how many times I was out in the cold dome in the front yard here, running the telescope system out there. Ugh. It was very cold, and sometimes winter was just miserable, like 5, 10 below zero. At least I was protected from the wind, but that cold, static, air in the building was just horrifying. It would just cut through you right to the bone. There's our parabolic curve that actually shows us the central focus point, and if we let it go all the way to the end, it'll refine and refine and refine, but it's pretty good right now, so we're going to say best focus. Alright, so it's going to go out and centralize itself on the bottom of the vertex, and we should be good now. So we can get rid of this. Each square is a sample, alright, for our stars. And now, this is the object I want to look at, I believe, but I gotta, actually, I know what I can do. I'll just do this, see if it recognizes it. Okay, it doesn't know the object, but Hipparchus 110.504 is known. So if we find 110.504, let's go in here, center up on this, and see where 110.504 is. That's Hipparchus 110.55. Use your fives. Use your inside 504. So where is that? Okay, see, we're pretty far away. So what I'm going to do is I am going to center that in the view, and then align, and then go back to the nebula. Alright, so it's going to be here. You'll notice how red it is. That's exactly the color that we saw in our planetarium program. That star, Hipparchus 110.504, if we come back and look at it, 110.504, it's a supergiant star. It's a K2, and it's a 1A. So it's actually very, very luminous supergiant. All right, and its distance is 3,800 light years. Okay, well, actually, no, it's not. It's 13,000 light years, which is kind of interesting. 13,500 light years. So it's very bright. Okay, so now that should be in the center. All right, so let's make sure it is. Yeah, close enough. And we'll get rid of our reticles. All right. And now we come back here, and we're going to center that. We're going to actually reformulate our telescope on that. And so now, if we want to come back to this object, we can say, sure, let's go right here to this star, and then we'll have dark nebula right near us, and it's going to move just a little bit. Now, of course, we can't see any nebula in here, but there is, and so we're going to just wait and see. Let's do this, see if it identifies anything in here. 110.504 is there now. But we're upside down. Okay. So I think we're good. Let me just look at that here, make sure. Oh yeah, there's our field of view. It's big. So 110.504 is literally on the edge of the field. It's upside down. So it's going to be to the lower left, and it is to the lower left, so we're good here. All right, so let's now take a deep photo of this, and we'll do this for 35 seconds. Okay. All right, and we're guiding, so now we'll go into our deep sky mode and just give it the best shot. That's our Cocoon Nebula that we shot earlier. As we mentioned. Very good. And its progress bar is behind the Asterian sign. Alright, so we should see it come in now. That's going to be beautiful processed. There we go. And so now we have this beautiful nebula here. And as I said, it doesn't really know where this is or what it is because it doesn't have that particular data. But we know, okay, this is actually, this object here is the Lion Nebula. And so we're going to call it the Lion Nebula in its name. There we are. Let's see what's hiding. I know it's only got 2 exposures, but let's really push it. Okay, so you can see that there's more hiding back there. Very cool. Ronald, I'm glad you're doing better. I know you're having some issues, but now that you're doing better, and you definitely have to make sure you take your medication. Before Ronald got to his house, Marianne and I saw it first because we drove to his house from the observatory just to check it out for him. We sent him a video. It's a really nice house. From his house in Jeffers, Minnesota, to the house in Benson. It's been something else. Really, really something else. I think your house in Benson is probably twice the size of the one you had in Jeffers. You lived on a postage stamp in Jeffers, and now you have at least an acre of land there, right? Yeah, okay. Yeah, you don't have to worry. Well, other people in Minnesota have to worry about the winter there, but you don't. That's correct. Oops, sorry. I made a mistake here. There we go. There we are. This little icon that's in the way here, that's the VCAM icon. And I have to buy VCAM in order to get rid of it, but it's nickel and diming you, you know. By the way, if you guys, please, follow us on TikTok. I mean, I just put in, I'm putting up highlights each time. I've got one from last night I got to do, and tonight I'll do that. I'll do all that tomorrow. So I'd love for you to check out our highlights reels that we put up there. And follow us, because I would very much like to get the TikTok stream going too. And I need more people so I can stream on TikTok. It's crazy. I can't do everything, you know. So if any of you know a social media director, I'm in the market, okay? We got to have a social media director help us with this stuff. I can't think of everything. Yeah, Ronald had 925 square foot house in Minnesota. Now he has 1,000 square feet more. Don't worry, he'll fill it. That house will be filled with junk before you know it. Then he'll say, hey, my house is filled with junk. Isabella, Ronald moved just recently, actually. And, of course, what happened when he first gets to Benson? He gets himself in the hospital. Jeez. You know, he just doesn't learn. All right, let's color correct. It's going to change the reds a little. There we go. Nice. Okay. Now we can push this a little bit, get that a little brighter. I don't see a line, but we do see dark nebula over here. Yes. Yeah, the Lion Nebula is beautiful. And there's also, down here is the other part of it. And I couldn't show you all of it. With a previous camera we used, the field was larger. But unfortunately, the larger field, we lost resolution, of course. So right now, the other half of the Lion Nebula is down here in this reflection nebula component down here. But we're just looking at the hydrogen emission component right here. Nice. Ronald, you're going to be panning for gold down there? You got to drive up north and go to like some of those little creeks and pan for gold. I recommend the creek. There's a creek going through Sedona. Hey, Marco. And that creek in Sedona has a lot of turns, and so there's a lot of bends where silt has piled up. And I bet you could find gold in those silt sumps there. Isabella, oh, says she almost moved out of the city. Well, Isabella, why would you move to the countryside where you could see the stars? You'd have to move quite far away from Sofia to see stars. I was looking at the world light map one time, looking at your location, and it was actually pretty bright around there. Yeah, so you see this blue nebula is coming in now. It looks really pretty. So you got this red one with details, and they got the other half down there. This is really one that is meant for mosaic. You know, you just take this part of it and put that up there in the corner and photograph all this region. Now I have 12 images here. I'll have 13 in a moment. Okay, it's too hot there. Isabella says too hot there. Far from everything. Yeah, that's one of the problems. When we're out in the Sonoran Desert, in this observatory right up here, we at least we have a bathroom. There's a house on the property that we can usually have access to, but the owners of the house haven't been there for a while, and the house rapidly rises in temperature. Now, there's a caretaker who's there all the time, but the house rose in temperature. At one point, the interior of the house was up so high that it was literally uninhabitable. The temperature was like an oven at like 130 degrees in the house. Maybe, and one thermometer said 150, but I doubt it. I think maybe it was broken. But that's pretty hot, and you couldn't stay in there for a long period of time. And Tara had to go out there to reconnect our Starlink because the folks that came out to replace a Viasat server, or router rather, just hooked every single cable they could find into the Viasat router, and we ended up with, 2 megabits per second going up. It's just terrible. And so I literally couldn't stream. So I had Tara go out there and check it out, and sure enough, they had plugged our Starlink router into the Viasat router, and that explained why the connection was going down every 10 seconds. It goes down, then it comes back, then it goes down, then it comes back. So by bypassing the Viasat router and going right to the Starlink router with our cable, we were able to fix the problem immediately, and we had Starlink back. Steven, Mr. Django, how you doing? How is Belgium today? Oh, you're in the south of Spain right now. Very nice. Yeah. Some folks, when they go on vacation for weeks. But then again, they work all year long every day. So, you figure, do the math. All right, I'm going to go to 18 frames, and we're going to stop there. And let me go to this while we're waiting. And let's back out a bit. Okay, there's a Lion Nebula. Notice that the Lion Nebula doesn't even show us. It doesn't show us the blue nebula down below, but it's there. So we're capturing it, but they're not showing it. Okay. Okay, now, alright, so we're probably going to look at this as the last object. The Elephant's Trunk Nebula. It's really a beautiful region, and this is the actual Elephant's Trunk right here, this guy. So we want to put this right about here. So we want it to go to like that star right there. So I'll just select it, and we'll get close. We'll get close. So let's come back here. We're going to go to 20, and then we're going to move on, and we'll go there to Elephant's Trunk and terminate this episode of Skytour Livestream. Here we go. 20, save, and save. Exactly. All right. There we go. So it's I'll just show you the whole image right now, actually, just so you can see what we're looking at. There's the whole image. Now what we'll do is we'll come back and we'll do a mosaic of this, add this in, and add the blue, and then do a mosaic later of all that, so you can get that. All right. That said, we have 21 stacked images. I'm going to save those, and then we're going to get out, and we're going to go back to our low light mode just so we can move on to the Elephant's Trunk. It's hard to go to bed when you got so many good things to see. But this will conclude our Milky Way tour. Part 3 anyway. Part 4 will take us into Cassiopeia, and that'll be later in the season, a little later in the season. But it's looking pretty good. Okay, so let's come back here and go to our planetarium, and we're gonna go into that one star right here, if the coordinates are correct. So let's do that. Okay, so we should be there right now. So far the telescope has worked very well at this point. I'm very happy that it's working. Alright, let's see now. There are those two stars, and I'm going to come back here. I'm familiar with those two stars. Okay. Okay. All right, here's what I'm gonna do. I'm gonna take a quick photo just to see where we stand, and then we'll correct our position if we need to. 20-second photo. I'll leave this over processing because we're gonna want to see what's going on. This will help us see that. Mr. Django says, always the diehards are online. Well, yeah, in the winter we're gonna be able to start and stop sooner. Okay, oh, that's actually perfect. That's exactly what I wanted. That exact frame. Good. All right, so we're gonna go and make this a 35-second photo, and we're going to live stack us here, and we're gonna drop out of warp. Okay, there we go. Pardon me, is Paul Prajalta online? Is Prajalta Prajalta? Paul Prajalta. If you've just joined us tonight, you weren't here last night or the night before, I forget when I did it. You didn't hear the story. I won't repeat it, but it's in the stream. You listen in the stream. Oh, look at that. Okay, so here is our final image for tonight. This is called the Elephant's Trunk Nebula. You can see the elephant's trunk right here. And you see two tiny stars in there, and then you'll notice as it gets better that this is an open cavity that's carved out by the hot stars inside of here. Their stellar winds are pushing gas and dust away and opening up a hole, which is what stars do. They open up a hole around them. And so we're getting one here, and you can see the background through this open hole. It's like an eye of a needle. Now I'm going to reduce a little bit of the red to make it more correct. There we go. This black area is a much more dense area of dust than up here. This dense area is thicker in cross section to us into the page and back, right? So inside there, it's possible that the temperatures are somewhere around absolute zero, maybe a little bit above, protected from the radiation of the stars outside that cloud that's light years in size, you know. And this is the Elephant's Trunk Nebula, as I said. In the Benson scope, this area shows beautifully, I would imagine. I haven't looked at it yet. I can't wait. So in our view, we have a bunch of different things that are well known. We have the elephant's trunk right here. And then this is what's called the caravan. That's just because it looks like camel humps. So that's just the popularized name. That's not really what these are. Okay. In fact, if I bring this up and do this, okay, you see that it knows the stars here. It doesn't even name this, but that's actually a very well-known object. It's called the elephant's trunk. So I'm going to name it Elephant's Trunk. Nebula. There we are. All right. And so we will actually, I'll save that with annotations. No, I don't want that. I'll save it with annotations. And there we go. And then we can get rid of this because we now know where we are. Now we have 5 images stacked. So we've literally, once we get to 6 right here, we'll have half the noise of an image that had only 3 exposures. Okay. And that's pretty cool. That's pretty cool. Sam S says, diehards? Where's skyhards? Yeah, you're absolutely right. Skyhards is a good way to put it. Sorry about that. Yeah. So you can see now, if I zoom in on this, you'll see a little better. Okay. Inside here, you see the hole, right? That hole is pretty interesting. That's the hole that is actually showing us the space behind it. You'll notice it's like a sort of a dark ring. That's dark dust in here with hydrogen gas. Where the dust is very dense, the hydrogen does not show through too well, and so we don't see it. However, where the hydrogen is dense, we see the hydrogen looking more red than a soft red. Okay, and that's what we're looking at right there. Yeah, this is beautiful. Okay, so we'll take this down just a notch to try and soften the noise in the background while we're waiting. You also notice that this star has a small reflection nebula right next to it. Right there, you can't miss it. And that's, again, dust that is scattering the blue light from that star. Okay, Isabella, thank you so much for coming. Yes, this telescope is fixed, and it's going to be converted to the same style and capability as the Benson telescope, and that'll be next month. At least that's the idea. So good night. Well, good day to you, Isabella. It's daytime in Bulgaria. See you later. Thank you so much for coming. Great to see you. All right, so we have 9 images stacked here. When we get to 10, we're going to have exactly half the noise of 5 exposures. It's sort of a rule of thumb. It's not exact, but it depends on a lot of things. But that's actually how it sort of works. So I'm going to pull this in now. Make that a little bit brighter, because I want you to see that there's some variations in this dust out here. See that? There's lighter and darker areas of dust in here, and they show very, very nicely in this nebula region. Very, very nice. And you might have heard me say before that life could not exist in these brighter regions because the ionization of hydrogen takes a lot of energy, and that energy is in the form of ultraviolet radiation, and that would sterilize planets and so forth, and possibly even rip off the atmospheres of planets, and that's not good. By the way, I'm wearing our Sky Tour live stream shirt, and on the back it shows all the planets, and it says, I need my space, and Pluto's included. So if you're interested in one of those shirts, you can go to our contact form at skytourlive.org and let us know. And we have a number of sizes left, and we'll get one out to you. All right. I believe it's $25 for a shirt. You know, if you don't want a shirt and you want something cool, well, you can go to Sky Tour Shop on Etsy and grab yourself sneakers with nebulas on them, socks, beach towels, mugs of all kinds. It's pretty cool, you know. We're at 12 images now, and you can see that it's starting to look better. We're starting to see more detail. And Michael has a question. He writes, Mark, quick question. How long to fully process an image? Is there a special setting that you pre-select? No. Okay, I use Photoshop to do all my processing. I don't use PixInsight or these other products that are special products because I don't want to have a canned routine do the work for me. I want to do the work so I understand how the processing works on images. You're stronger that way as a technician if you actually know the science behind it. So that's kind of where I go. Translation. I'm a nerd. I want to do it myself. Okay, but I did write for Photoshop. I wrote things called actions, and actions are used to actually do some housekeeping stuff that happens all the time. And so I have processing I do with these actions. If you guys want one, just like I said, go, if you're a t-shirt, go to skyterlive.org and go to our contact form. And Marianne will get the contact form result, and she'll look and make sure we have your size, and she'll ship it out to you. Again, it's a $25 donation. It is a donation. And by the way, it's a write-off because we are a nonprofit organization. Anything you give to us is a write-off. So all of you that are Patreon subscribers, all of your money is write-off. So if you put in, say, $500 a year, or $100 a month, $1,000 a year, that's a complete write-off for you at the end of the year. All right, so just so you know. Look at how beautiful this is looking, I'm going to do this again because I just have to. I'm going to drop that out of the way, and I'm going to take out our telescope out of the view, and I'm just going to bring us this image full screen, because why not? Look at that. That is so beautiful. The hole here is showing up very nicely as well. Gee, that's something. I'm telling you, it's so easy to be taken aback by all this stuff, don't you think? Like the hole right there, that little hole is created by this star in there that you see. There's a second star in there too, by the way, which is actually helping to blow out a lot of that dust in there and the gas in this particular region, right? Then up here, we have this dark region here. And again, as I've told you before, life began in the dark, and it's up there where life may actually be getting a foothold, and there might be a planet that's being made inside there, and a star that may be forming in there. And I'll tell you this, that location, as well as this one over here and over here, it could be so dense that you might not even see the star once it forms. It may be locked in the dark and be, shining from within the dark, and the only way you can see it was with an infrared telescope like the James Webb. So I'm interested in having the James Webb focus on this site right here and seeing if there are stars inside this nebula that are hidden. My guess, yes, there are. If you notice around the edge of this, okay, around the edge of that black object, okay, you see that there's a sort of a light color. We're actually seeing how, as the dust gets thinner there, we're starting to see through it a little more. And Michael has a question, says, Mark, can you measure time by how much dust has been blown out from the star? Oh, good call. Yes, if we know the type of star, we have a pretty good idea about the stellar wind associated with such a star. And so we can figure out how far it's blown out, but there's a much simpler way to do that. And that is by looking at the star, we can also do a calculation and figure out, using the cosmological distance ladder, how far the star is. And if we know how far the star is, then I have a program I wrote which can actually tell you exactly how big this hole is. It's several light years across, without a doubt. And if you're on this planet, let's go inside. Let's say there's a planet in here, okay, and you're here, and that's actually quite beautiful. You're on inside this ring. Inside here, you might see a little arc of a nebula near you, so to speak, just a couple light years away from you. But you might actually have much of the sky hidden from you because of this dense ring, depending on which way you're looking from. So that's, again, something else. We're used to seeing everything in the sky, saying, hey, we've got no dust around us. But is that true? The answer is maybe not. The latest research shows that the stars of the Pleiades, okay, may very well have, which you don't have dust around them. Those stars of the Pleiades may very well actually have dust clouds that extend to us and we're about 400 light years away from the Pleiades. So maybe we're in a large, several hundred light year long dark dust cloud, and that's actually very possible, and very much on the table for a possibility. Yes, sir. All right, so let me all right, we're at 23 images here. I'm going to do a color balance one more time. Okay. And when you do color balances later on in the imaging, the color balance changes less and less and less. And when I just did it, it didn't change at all. And that shows that we're looking at a proper color balance here. That's gorgeous. That's really gorgeous. You can see the subtle convolutions in this dark nebula reaching over here. Again, this is the elephant's trunk. All right. Wow. What'd you think? Was that pretty cool or what? I'm going to save this now with 24, and I'll save it again with 25 in just a moment. Let's come back up here. That's so pretty. I'm going to see if we can actually coax a little more. Not that. I want to see if I can coax a little more detail out of this by actually increasing the radius of our sharpening. That does help a little bit. You can see when you increase the sharpening, it increases the noise. So you have to kind of, everything's an art. It's an art of the balance, right? You can see the light, dark areas here versus the dark areas. They're higher and lower density areas. Very nice. Every one of these dark clouds in the galaxy and all the hydrogen clouds, they're all shaped by galactic rotation, by the movements of the stars, by gravity, and by stellar winds of stars in the area. That shape comes from all of that. All right, so let's redock our window here. Come back here, and let's see what it wants. So yeah, it brings us down just a little bit. It keeps our dark level though where it was before, which is great. All right, and I can bring this up here a little bit. Sorry about that moment of 10 or 15 minutes where we lost connection, but it was a Starlink outage, and I think we're good. Knowing it was a Starlink outage, I knew they were going to go into a panic until they fixed it. So I'm glad I waited it out, because I wanted to see this tonight. Yeah, I'm a nerd. And you know what? So are you guys. Hey, sorry if the shoe fits. That's okay. We're nerds. Nerds are great. Oh yeah, so much detail in here. And you know what the nice thing is? Because we're at such a northern location, we don't get satellites passing through here. There's north-south polar birds, typically spy satellites, but we don't see them. We don't see them because we just get lucky, you know? Okay. Remember, guys, if you want one of these shirts, go to skytourlive.org. You hit the contact form, send a message. I will see it, or Marianne will see it, or Tara will see it. And if our size is there, for a $25 donation, you can have one of these shirts. They're really, really nice. They're so comfortable. I wore mine when I got it from the place, and it was comfortable before even washing it. That's how comfortable the shirts are. It's really, really nice fabric. Okay, 30 is the limit. No, not the limit. I'm just going to make it the limit. Okay, 30 exposures. So when we had 15 exposures, we had twice as much noise. Now at 30, we have half as much noise as with 15 exposures. And that shows when you zoom in. You can actually see that it looks pretty good, you know. There we go. Now we even see detail within here. You can see another dark spot there. All that was invisible before. We couldn't see that. All right. Well, guys, this is amazing. You've done this. Let me bring our telescope back here. There we go. I like that, being able to move things. Okay, and so now it's time to sign off. It's 1:30 in the morning here. Thank you so much for joining us on part 3 of our Summer Milky Way Sky Tour. And the next time we'll do part 4 and take ourselves further down into the winter Milky Way a little bit, Cassiopeia and that area, and we'll be able to do all kinds of things there. Yeah. You know, Sam S., you bring up a point. He says Sky Nerds. I'll bet you if I changed my channel name to Sky Nerds, I'd get way more people. Oh well, what can I say? Alright, so that said, I save this. I'm going to save it one more time. And save it exactly as seen. Okay, tomorrow I'll do processing on this one. That's going to be beautiful. Whew, wow, this is great. Okay. Well, guys, thank you so much. It was a pleasure having you with us tonight, having you with me tonight. Enjoy your company all the time. Support us any way you can. We love it. We need it. And I look forward to doing this again for you. So hopefully you guys have a really good night. I'm sure that you will. You guys are fantastic. Thanks again for coming. And thank you to all of you that are moderators that are helping as well. Notice we don't have a whole lot of people that we have to kick out. We did at one point. But now, people don't really mess with us that much anymore, and I think that's pretty cool. All right, guys. Sayonara. See you again, and we'll talk very soon, all right? So, good night, everybody. This was fun. This was really fun. Good night.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. your eyes to the skies, universe in all its light. Sky tours bringing the views. Every